Section 2.2, Part 1, so conditional statements. So a conditional statement is something that involves a hypothesis and a conclusion. So usually we see them in if-then form. That's the most common conditional statement. So it will say, if this is true, then this must be true. Okay? So we have a lot of statements in today's lecture. Some of them are like nonsense statements. I think there's one about like an alligator with a purse, or a lady giraffe carrying a purse or something like that. So sometimes they're nonsense, but we're going to just use it to understand the if-then form and how to change things around, okay? So I always say that geometry is perfect for those of you that are the future lawyers of the world. Are some of you guys good at arguing your case? Maybe. Have you met people like that can always argue their way out of anything? Yeah, those are the lawyers of the world. And they're usually good at geometry because it's definitely like you have to show like a proof, a reason why things are true. Okay. So the first example, it says, find the hypothesis and conclusion in the following statements. So if you know where you want to go, you have a better chance of getting there. So think about the if and then the then. So our hypothesis is going to be, you know where you want to go. And the conclusion is, you have a better chance of getting there. Okay. So the next one, a great work of art is made out of a combination of obedience and liberty. So what are we saying when we put it in like if-then form? We're saying if a work is great, so let's say the hypothesis is a work is great. And our conclusion is then it must be made out of a combination of obedience and liberty. Very fun to write all this out, right? All right, so C, if I could paint a flower that is, paint that flower in a huge scale, you could not ignore its beauty. Do you guys see the if and the then? So I could paint a flower in a huge scale, that's our hypothesis. You could not ignore its beauty, that's our conclusion. Okay. Sometimes things aren't always in that direction, though. It doesn't always say, if this is true, then that is true. Sometimes it has the if at the end of the statement. Okay, so we're going to rewrite some of these in if-then form. So a number that is divisible by 25 is also divisible by 5. So what do you think, Keegan?
Like if a number is divisible by 25, then it also is also divisible.
Uh-huh. All right, I'm using some shorthand here. Are you guys good with this?
Yeah.
If a number. It doesn't say if a hashtag. Like that's how we abbreviate number. If a number is divisible by 25, then it is also divisible by 5. Do you know it's also called a pound symbol? Do you guys know that?
Yep.
Yeah. All right, so try the next one. So try to write it in if-then form. So a person over the age of 16 and 3 months is eligible for a driver's license. So what are we going to say? If a
person is over the age of 16 and 3 months, then they're eligible for a driver's license.
I didn't write my English teachers would be upset with me because I said if a person and then I said they on the other. I should say he or she or whatever. I should make them both plural maybe. If people are over the age of we'll go with it. Don't tell your dad, Keegan. All right, so where all think alike, no one thinks much. So how about we just don't write some of these down, but we talk about them. So where all think alike, no one thinks much. If all think alike, then no one thinks much. Are we seeing this? Okay, how about this one? So D, two angles have the same measure if they are congruent. This is the hypothesis here. But we want to phrase it kind of nicely. We don't want to start out with if they are congruent. So let's say if two angles are congruent. So if two angles are congruent. Look at all this shorthand and geometry we can write. See how I wrote it? If two angles are congruent. Then they have the same measure. Okay, does that make sense? Okay, so this can be particularly difficult for students that maybe learned English as like a second language. So if you didn't speak English when you were first born, this chapter could be really hard for you. So if you have issues, let me know. Who speaks English when they're first born? With the first language that you learn. All right, so Venn diagrams are diagrams that show all logical relations between a finite collection of different sets. We often use Venn diagrams in logic. So Mrs. Armato is really big on these Venn diagrams, so I added these into the notes. So here's a Venn diagram, and we'll talk about this Venn diagram later in the year. That has to do with quadrilaterals. Do you guys know what a quadrilateral is? Quad means four, so what do we think? A four-sided shape, exactly. So quadrilaterals can be broken into multiple things. So we can have parallelograms. Parallelograms are where two sides are parallel, or two pairs of opposite sides are parallel. And then parallelograms, within them we have rectangles. Within parallelograms we also have rhombuses. And together, rectangles and rhombuses create squares. Okay, so a rectangle has four right angles. A rhombus has all sides congruent. So a square is its baby, as I always say. It's the one that has four right angles and all four sides congruent. Okay, does this make sense? We're going to do a lot with this later in another chapter. It doesn't matter right now. But let's look at the Venn diagram. So it says if a shape is a parallelogram, then it is also a what? Ah, no, tricky. Then it is also a quadrilateral. If we know it's a parallelogram, then the only thing we can guarantee that it also is outside of it. It's a quadrilateral. So it is also a quadrilateral. If a shape is both a rectangle and a rhombus, then it is also a square. So it's tricky. So if I was talking about if P, then Q, so we just said if a shape is a parallelogram, then it is also a quadrilateral. Isn't that nice that we have P and Q here? I didn't even plan on that. We always use P and Q in logic. So if it's a parallelogram, then it's a quadrilateral. What did the Venn diagram look like? So we had one thing inside of another, right? We had the quadrilateral here, and we had the parallelogram here. Okay, so that's going to be important to us. So if we have the if part, the if is on the inside, and the then is on the outside. All right, so it says make a Venn diagram to represent any if P, then Q. So I did that right there. So we have P on the inside, Q on the outside. So our if is on the inside, our Q is on the outside. So it says identify the hypothesis and the conclusion. Now some of these are not necessarily true, and we tried to make some of them so they're not true. Because in the next section, we're going to be talking about, are we allowed to move things around? Are we allowed to say, so if I start with, if today is a Saturday, then there is no school. That's true. If it's Saturday, we're not going to have school, right? So our hypothesis is today is Saturday. I started capitalizing there. And our conclusion is there is no school. And what its Venn diagram would look like would be the if P. It would say Saturday in here. And then outside would say no school. Now, are there other reasons that we wouldn't have school? For instance, next week, right? Why do we not have school next week? There's a holiday, a Jewish holiday, right? Rosh Hashanah. So there are other days that we wouldn't have school, not just on Saturdays. Or maybe you have a faculty work day, right? Or maybe it's the day of prom. You guys get the day of prom off so you can do your hair and nails. Did you know that? Very exciting. And we sit in faculty meetings all day. It's another faculty work day. So there are other days that you may not have school, not just Saturdays. Okay, does that make sense? Sundays, right? So when I switch it around, if there is no school, then today must be a Saturday. Does that make sense? No, that's what we call the converse, and we're going to be talking about that in the next section. We switched the hypothesis and conclusion. And when we do that, it's not always making it a true statement. Okay, so now our hypothesis is no school, then today is Saturday. And we said that this one's not true. And I told you that it's a word called the converse, which we're going to talk about eventually. So its Venn diagram would look like this. On the inside, we would have no school, and we'd say Saturday. In other words, every single Saturday. So if it's Saturday, that's the only time we have no school. That doesn't really make sense that way. Okay, so each of the following statements is a conditional statement in disguise. So some of them are weird, like I was telling you. Mrs. Armato loves these weird ones. And the reason is because do you guys know who wrote Alice in Wonderland? Do you know what his name is? Something Carroll, let me think. What was it? I have it somewhere. Yeah, Lewis Carroll. So Lewis Carroll was like a master of logic, and he would put all these like crazy ones, like the lady giraffe one is his. So he would always do like really weird statements so you wouldn't get confused about like, oh, well, that is true because this is a real life situation and that is true in that real life. So he would always just make gibberish. Okay, so all birds have wings. So what would we do for if then form, first of all? If it is a bird, then it has wings, right? So if it is a bird, then it has wings. All right, so how about B? So Charlie Brown forgets to feed Snoopy if he is upset. So if Charlie Brown is upset, then he forgets to feed Snoopy. That's sad. Or as my kids call him, Snoopy. They put an F in there. They have a little stuffed animal that they call Snoopy. All right, so a lady giraffe always carries a handbag. That's the weird one, right? So if the giraffe is a lady, then she carries a handbag. They're weird, aren't they? All right, do these make sense? I don't know why I did two B's. That's a C, I guess, and this is a D and E. All right, so long hours of practice are necessary. So I'm going to talk about necessary and sufficient another day because I think it's a weird one, and I had trouble with it when I was in school, and I still haven't I'm having a hard time thinking of how to explain it to you guys. So I'll find a way to explain this to you, but we'll stop with those two, and then we'll go on to the next ones. So let's try this. So this would be F and G. I think I mislabeled. So you can have a treat if you get all your chores done. So what would we say for that one? If you get all your chores done, then you can have a treat. So you don't have to write it. If you get it, you don't have to write it down. All right, and then the last one, no one likes doing chores. That's weird when you say no one. That is exactly right, Keegan. If you are a person, then you don't like doing chores. So if you are a person. Aren't they strange? So sometimes it feels a little forced to put it in if then. That feels a little forced to be like, if you're a person. If you exist. All right, so the next one. All the people at the game were fans. So what do we think? If you were at the game, then you were a fan. So what if I say all the fans were at the game? If you were a fan, then you were at the game. And that's kind of how the necessary and sufficient is. It's like one of them's backwards from the other one. So we'll talk about that eventually. Okay, none of my friends like the pizza. If you are my friend, then you do not like the pizza. Exactly. And I will get an A only if I study hard. Yeah, if you got an A, then you studied hard. I don't know. Only if, that's a weird one. So if you study hard, then you get an A.
Yeah.
This is one of those necessary ones as well. So we'll talk about that when we talk about the necessary. All right, so any 2 points are collinear.
If 2 points exist.
Yeah. If you have 2 points, right? If there are 2 points, then they are collinear, or you can draw a line through them. So sometimes it takes some little adjusting with the words. All right, so it says let statements P, Q, R, and S, and T be as followed. So A and B are vertical angles, A and B are a linear pair, A and B are supplementary, A and B are adjacent, A and B are congruent. All right, so P implies R. So what would P implies R say? It would say if, so this means if P, then R. That's what that means. When you see that little arrow, it means implies. So P implies R. If P, then R happens. Maybe I won't do an arrow, that's confusing. So we're saying if A and B are vertical angles, so angle A and angle B are vertical angles, then, and then we look at R, A and angle B are supplementary. Can that happen? Does that always happen? So if A and B are vertical angles, are A and B always supplementary? No. So would you call this a true statement? It could be true, but would you say it is always true? No. If it's not always true, then we write false. So we're going to say false. So if you want to write in parentheses, could be true, but not always. That's how we decide the validity of a statement. If it's always true, then we'll say true. All right, T implies P. So if T, then P. So we're going to say if angle A and angle B are congruent, then angle A and angle B are supplementary. So that could be true, right? If they were both 90 degrees, they'd be supplementary. Congruent and supplementary. Is it always true? No. So again, we write false. Is this making sense? So we're just rewriting it based on the symbols. So we'll do a lot of symbol writing in this chapter as well. So this like P implies Q thing. Okay, so the next one, P implies T. So let's find one that does work. P implies T. A and B are vertical angles. So if A and B are vertical angles, then A and B are congruent angles. Is that true? Vertical angles, are they always congruent?
Yeah.
Yeah, so if angle A and angle B are vertical angles, then angle A and angle B are congruent angles. And that is true. But what if I do it in the other direction? What if I said T implies P? If I said A and B are congruent angles, so if A and B are congruent angles, then A and B are vertical angles. Would that be true? Are congruent angles always vertical? Not necessarily. Does that make sense? Do you guys get it? So the order that we go matters. So the if and the then matters. All right, is this making sense? Let's skip down to F. So S and T implies R. So S and T is A and B are adjacent and A and B are congruent. So we could put those together and we could say A and B are adjacent and congruent angles. So if angle A and angle B are adjacent and congruent angles, then, and what was R? A and B are supplementary. Okay, so if they're next to each other and they're congruent, do they have to be supplementary? So this would be like adjacent angles. What if they're both congruent? So what if I had 50 and 50?
They're not supplementary.
They could be, but not necessarily, so we put false. Did I say draw a counterexample too? Okay, so let's draw some counterexamples on these other ones. So for part A, we said if A and B are vertical angles, then they are supplementary. So that's not necessarily true. We could have things like this where it's 50 and 50. Those are not supplementary. If A and B are congruent, then A and B are supplementary. No, because again, we could have like an 80 and 80. Those are congruent angles, but they don't add up to be 180. So these would be counterexamples. Do we feel good with counterexamples? All right, is that the end of the section? I think it is, isn't it? Yeah. Okay, so do we understand kind of this first little bit of 2-2? All right, so stop there.